Hello, welcome. This is a video on how to solve right triangles, and this is at the approaching level. They have given us the information that says, given a right triangle with a side and angle, lowercase b equals 16, that's a side length. When they'll have the lowercase letters, we're talking about side lengths. A equals 47 degrees. One, it's a capital letter, so it's an angle, but also it says degrees. And so that's another indication that we're looking at degrees. Find the value of the missing sides A and C and the angle B. Now, I know that somebody here was very well-meaning, but I like to list out everything that I've got. So I'm going to put sides and angles. And then I'm going to list what I've got here. Sides, I know a little a, little b, and little c. And angles, capital A, capital B, and capital C. And most of the time, capital C is going to be 90 degrees. So we're going to go ahead and just write, that's what we know. We know that this C is 90 degrees. And then A is 47 degrees, so we're going to write that in there too. 47 degrees. They've given us the little b is 16. Little b here is 16. And so now we can see what we're looking for is looking for big B, little a, little c, and that's what solving a triangle means. It means getting all of the information there. So again, we don't have a diagram, so we're going to draw a diagram. Just a random right triangle that we can hang our thoughts on. Doesn't matter if it represents the triangle that we have or not. But you do want to make sure that you have one that's a right angle like we have there. So like I said, this is typically going to be C, then this would be little c. And then you can decide where you want to put A and B. You can put A here or down here. I'm going to choose to put it up there this time just to keep it real here. Opposite big A then would be little a, and opposite big B would be little b. That's opposite. So when we draw the arrow out, that's what that means. Now, let's fill in what we've got. I know little b is 16. So I know that. I know that A is 47 degrees. So I'm going to write that in here, 47 degrees. And then, and I think that's it. That's all I know. But if I want to know what B is, I can just use the triangle sum theorem. You remember that sometimes you'll see it with this little m, the measure of angle A plus the measure of angle B plus the measure of angle C in any triangle, those have to add to 180 degrees. That's the triangle sum theorem. But we know that the measure of angle C is 90 degrees. And we know that the measure of angle A is 47 degrees. So if I subtract both of those, minus 47 and minus 47 from both sides of the equal sign, and then that would cancel those. And then if I subtract 90 from both sides of the equal sign, that would cancel those. And then I'm going to be left with the measure of angle B. When I put that in my calculator, when I do it by hand, I'm going to put it in the calculator. It's kind of late in the day and I'm tired. So 180 degrees minus 47, and then again minus 90. And that gives us 43 degrees. So I can say this is equal to 43 degrees. And I'll go back over here. And B, again, it's written up here, but if it weren't written there, this is how I would have you write it so that you can see. Here's my sides, here's my angles. I'm keeping track. My angles are all degrees. My sides were whatever they are. They didn't give us units here. Nope, no units. But if they had said it was inches or feet or whatever, we would include that. And so now we know that B is 43 degrees. You could write it here as well if you'd like. Now, side lengths. Little a, how do I know what little a is? I know B, I'm going to go ahead. I'm going to clear this out so that I have some space to work. Forgive me. You need to make sure you show your work. So plan accordingly. This is opposite. I have decided to find A first. I know that this is what I want to know, and this is one I do know. And so it's the a leg. So it's right next to the angle A. So I'm going to call this one adjacent. So I've got adjacent and I've got opposite. So if I'm going to my mnemonic, so ga doa, then I look at this and say, well, I've got O and A. Okay, that's O and A. That's the tangent. And so that's what I'm going to use, the tangent. The tangent of 47 degrees is equal to the opposite, which is A, over the adjacent, which is 16. And then to solve this, because I've got the variable up on the numerator, that's what we like, because when it's down on the denominator, it adds an extra step. I'm going to multiply both sides by, let's change this color here. I'm going to multiply both sides by 16. And that will cancel that 16. And then A is alone. So this is just what I put in my calculator, 16 times the tangent of 47 degrees. So I'll go back over here and put 16 times the tangent of 47 degrees. And that would give me 17.157. That rounds to 17.16. Now, make sure your calculator's in degrees. I've talked about this in other videos. If you don't know how to put it in the degrees, please let me know. 17.16. So A is approximately 17.16. 17.16. A is approximately 17.16. Now we need to find C, and I've got options now. I can use another trig ratio, or I can use the Pythagorean theorem because I now have two sides. You couldn't use the Pythagorean theorem if you only have one. You got to use a trig ratio. But when you have two sides, I now know that A is approximately 17.16. So I can use the Pythagorean theorem to find what C is, or I can use the trig ratio again. Let's see. I think I'll use a trig ratio again. But this time, I'm going to ignore this, that this is the opposite. Or if you'd like, I'm just going to kind of cross it out. Not because it's wrong, but because now I'm going to focus on the fact that here I've got adjacent, and over here I have the hypotenuse. And so I'm going to use a different color. I'm going to go blue. That's adjacent here, and the hypotenuse, because this is the one I know, and this is the one I want to know. And it's better to use the one that we were given rather than one that we've found. I could use that one also, but it doesn't give me an accurate measure because I rounded that to 17.16. So we want to use the 16 rather than using the 17.16. You still can. It's just you're going to increase your error every time you do that. So I look over here and I say, wait, I got A and I got H. A and H, that's the cosine. So this time I'm going to write the cosine of the angle 47 degrees. There are several ways to do this, you guys, because I also know that this is 43 degrees. So if I wanted to, I could use that one instead. It's okay. We're going to stick with what we're doing here. So 47 degrees, cosine of 47 degrees is A over H. A is 16 over H, which is our C. And so I'm going to multiply both sides by C times C to get it out of the denominator. And then I'm going to divide both sides by the cosine of 47 degrees. And so I've got 16 over the cosine of 47, because over here these would cancel, and I've got C alone. So then this is what I have in the calculator: 16 divided by cosine of 47 degrees. 16 divided by the cosine of 47 degrees. and that gives me 23.46. So C is approximately 23.46. 23.46. Okay, so good. Now I'm going to write that in here. C is approximately 23.46. And down here, 23.46. And there's some things that I'd like you to notice about the answers here. We can also kind of check. We can use the Pythagorean theorem. We didn't use the Pythagorean theorem to find this. We used trig ratios. But I could use the Pythagorean theorem to check it. And so let's take a look at that and see what does this look like. In any triangle, opposite the largest side is the largest, the largest angle is the largest side. And that's true here. 90 degrees is the largest angle, 23.46 is the largest side. The next largest angle should be opposite the next largest side. And yes, 17.16 is bigger than 16. And the smallest angle should be opposite the smallest side. And that also holds true. So just to check your reasonableness, depending on how much time you have to check your work, that's something that you can do, is just check to see, does my answer make sense? My hypotenuse has to be the largest side. And my smallest side should be opposite the smallest angle. Now, with that said, I could check and see, is 17.16 squared plus 16 squared, is this going to be equal to 23.46 squared? Is the length of one leg squared plus the length of the other leg squared equal to the length of the hypotenuse squared? And here, here I don't yet know. I don't expect that they're going to be equal, because on the one hand, I've rounded them. But let's see. I've got 17.16 squared plus, what was the other one? 16 squared. And I hit enter, and that gives me 550.4656. But if I take 23.46, and I square that, I would get something really close. Now, they're not exactly equal, but the reason they're not exactly equal is because we rounded to get those numbers. But they're pretty close, and so that's a good check. I can be confident that that answer I could turn in and be happy with it. All right. Keep working hard. You got this.